Greetings of the day. Welcome to all. Myself, Dr. Purandhar N, Assistant Professor, Department of CSE, Artificial Intelligence, MITS Madanapalli. Uh, Today, I'm going to discuss about searching techniques. The outline of my topics are Introduction to Searching, Searching Techniques, Linear Search, Example for Linear Search, Binary Search Example, Linear Search versus Binary Search, and finally my presentation will end with applications of searching techniques. So first, coming to introduction to searching. Searching is nothing but it is a process of finding a particular value or a key in the given collection of values. And here the collection may be an array, a list, or a tree, or a graph, or any structured data. So given any of these collection type of values, so we are going to find a particular key or a value in that particular list. So for this, whatever the process we are following, so it is going to be known as searching. And here are the examples we have. Searching for a contact number in a phone from 100 of contacts. So we can search a contact of a particular contact number from 100 of contact numbers which are available in the phone. And another example, searching for a file in a computer, navigating or going through a file system. This is another. So in our system, we are going to maintain many files in the form of directories and subdirectories. So whenever we are searching for a particular file, we are moving from root directory, subdirectories like this. And finally, we are going to find a particular file, whatever that is required. So this process also comes under the process of searching. So next, why we need this searching? So if you go the real-time applications in terms of computer technology, so we are going to use the searching techniques in many places. A few of them are represented here. First one, retrieval of information. So given a large data set, I want to find if I want to find a particular value or a element in that large data set without searching every element in the list, so I can follow a particular searching technique so that within minimum time I can find out or I can retrieve the data whatever I require. And second, data organization. So again the thing is we have a particular data organization technique. So in that we are going to store the data, and after storing the data, if you want to search a particular element, so then if you follow appropriate data organization technique, so then I can find that particular element whatever I require. Next, third one, algorithm design. Many algorithms and computational tasks depends on the searching algorithm. So they are going to design the algorithms and whatever the methodologies based on the searching techniques what we are going to apply. So from these observations, we can say that we need to know about, we are going to use the searching techniques at a different areas in the computers. Next, coming to searching techniques, uh, we can broadly categorize the searching techniques in two categories. So internal searching and external searching. Internal searching refers to the algorithms what we are following or what we are going to apply on the main memory. It is typically used for the data sets which will be fitted on directly into the memory, small memory. So if you have very small amount of data set and it is possible to store all this data in the main memory, so then I can go to use the internal searching techniques, and the examples which will come under this searching techniques are linear search, binary search and other techniques. And coming to other second category, external searching techniques. So whenever we have large data sets which are stored on the external storages, and magnetic tapes or magnetic disks. So if you want to find a particular value or a particular record from that large data storage, so then I'm going to use this external searching techniques where we can minimize the disk access. So without searching every record in that database or in that memory, I can search with the minimum number of disk access. So the examples which will come under this categories, B plus tree search, external hashing, and many more. And first we'll start with the linear search. So linear search, if you consider the process how it will works, so it will examine or it will searches each element list by list, one by one, until the target value is found or at the end of the list is reached. So it is going to apply the process in such a way that it will follow the sequential approach, and it will search or checks element by element, one by one, if any with respect to your target value. So if it is found, so there it will stop the process, otherwise it will go up to end of the list, so until we are our target element is found or not. If it is not found, we can stop the process. And it can be applied for both sorted and unsorted elements. So linear search can be applied for the list of values where the list is in sorted order or unsorted order, whatever it is, I can apply this linear search technique. And linear search does not require any additional data structure or any memory allocation beyond the input list whatever we are providing. Only with the given memory, with the memory whatever that is allocated for the list whatever we created, based on that memory only without any additional data structure or memory. So the linear search will identify the target element in the given list of elements. And the time complexity of the linear search is as follows. So in the best case it will take order of 1, in the average case and in the worst case it will take order of n. And here is the algorithm or pseudocode for implementing the linear search process. Here the name of the pseudo function is a linear search, and it will take two arguments, array and a target. And array is the list of values from where we need to search the element, search the target element, and the target is the argument which indicates what is the value that we need to, what is the element that we need to search in the given list. And coming to here, we are going to iterate through your list of elements one by one, and we are going to we are going to check the target element whether it is found in that list or not. So it will starts from taking the index value I value 0 to array length of array minus 1. And initially we start with first element array of 0, and we are going to compare with the target element. So if the array element in the location whatever is specified is equal to the target element, then I will return that particular index value which indicates the location of the target value. Otherwise it will go to the next element, second element. Again the second element is compared with the target element. So if it is matched, then we are going to return the index. So otherwise the process will be repeated. So if the given target element was found within the given elements, list of elements, it will return the index. Otherwise, if all the elements are searched and the target element was not found, so then it will return minus 1. So if you are from this function, if you are getting the index means the index will represent the location of the element where it was there. If this function returns minus 1 means it will refers to unsuccessful search, and the element was not found in that list. And here is the example to implement that linear search process. So let us consider we have the elements in the list like 18, 35, 78, 23, 19, 709, and a target element that we want to search is, that is 19. So according to the algorithm what explained previously, So it will start by taking the index I equal to 0. So I equal to 0, it will search the element. So k of 0 is compared with the your target, that is the item. Okay, so that is 18 is compared with the 19. So both are not equal, it will return false. Next, it will go to the next I equal to 1. So it will take the k of one item, that is a 35. 35 is compared with the target element 19, and again it is not equal, so it will returns false. So like this, the process will be repeated through all the elements until the target element was found in that particular list. So now whenever we reach I equal to 4, so it will search for k of 4 item, so that is a 19, and the target element is 19. So both are match is there successful. A successful match is there. That means the target element was found at the index location 4, so it will return true. So whenever we got this condition as a true, so that is the indication that the element that we want to search in that list was found there, and it will be returned as, and it will return the index location I equal to 4. That I equal to 4 refers the location of the element where we found that particular target element. So this is regarding linear search example. Next, we will move to binary search. So the binary search works by dividing the search interval in the half, comparing the target value to the middle element, and deciding which half to continue for searching process. So the basic idea in this binary search is, so it is going to divide the element into approximately equal halves, and it will compare the target element with the middle element, and based on the criteria, so it is going to search the given element either in the left half or right half. And the binary search can only be performed on sorted elements. So previously, if you consider linear search, so the elements can be either in sorted order or unsorted order. But here in the binary search, we have one limitation that the element should be in sorted order. Next, binary search, even though we have this limitation, it will performs well by reducing intensively. It is reducing the number of comparisons that are needed to find the target element in the given list of elements by the approach called as divide and conquer technique. So the whatever the list of elements we are giving, so it will be divided, and based on the element, the target element with respect to the middle element, so it will divide, it will such continue the search process either in the lower half of the elements or in higher half of the elements. So this approach technically we can call as divide and conquer technique. And coming to time complexity of this binary search, so order of 1 is for best case, and order of log n is the average case and for worst case. And here is the algorithm or pseudo code for implementing the binary search process. So this method or this function also takes two arguments. One is a target and other one is array. Array is the list of values that we want to search, and target is the element that we need to find out in that particular list of values. So initially it will start the index values with respect to the low as a 0, and high will be considering as a length of array minus 1. And we have a low iterative statement here. So this iterative statement will continuously reduces the given list of elements into half by comparing the target element with the middle element. So initially we are calculating the mid value. So mid value we calculated by low plus high divided by 2, and after getting that mid value, we are going to take that mid value as the index position, and in that given array we are going to check the element which is found at the mid location with the target value. Here three cases are possible. First case is the mid value or the mid location value may be equal to directly your target element, then it will return the mid as a location where we found the target element. Otherwise, there are two other cases are there. First one, the second possibility is that your target element may be in lower half or higher half of the elements. So if your array of mid is less than target, it means that the second element, the target element is available in the higher half of the elements. So then we need to modify the pointer low pointer with mid plus 1. Otherwise, it is a meaning that the target element is available at the lower half of the elements. So then we are going to modify the index high is equal to mid minus 1. So this process will be repeated until your target element was found in the given list, and it is represented with the condition as low less than or equal to high. And if the target element was found in the given list, then it will return the mid value. That mid value will indicate the location of the element where it was found. Suppose if the target element was not found in the given list, then it will return minus 1. So this minus 1 indicates that the target element was not found, and it will lead to the unsuccessful search. And here is the example for binary search. So here the given list of values are 12, 14, 25, 39, 41, 56, 78, 88, 90. And the target value that I want to find is 41 in the given list of elements. And here, for better understanding, the values are represented with the corresponding index positions starting from 0, 1, 2, 3 up to 8. According to the algorithm or the process what we explained previously, initially we start with the low equal to 0, high is equal to 8, and that is a last index, and the target value is 88. So now we are going to calculate first of all mid value. Mid is equal to low plus high divided by 2, that is equal to 0 plus 8 divided by 2, we will get 4, and the value is 41 here. So actually the target that we need to search is 88. So 88 is greater than 41. So therefore we are going to change that particular low index position to mid plus 1, that is equal to 5, and a high value will be taken as it will be considered high equal to 8 as it is. And step 2, next we step 2 here, next step 2 here. So based on the previous step, we are going to reduce half of the element from the search process, and we are going to search the given value at the higher second half of the elements. Now the low pointer is 5, high pointer index is 8, and the target is 88 here. And again we are going to calculate the mid position with the low plus high divided by 2, that is 5 plus 8 divided by 2, it will be rounded to integer, that is a 6, and the sixth in the sixth location the value that is available is 78. So again we are comparing the target value with 78. So 88 is greater than 78. It says that the given value is available in again in the second high, higher half of the elements. So therefore again we are going to modify the low pointer to mid plus 1, that is 7, and the highest value we are going to high index value we are going to take as 8. Now the search process will come to an end. We are going to search only the values which are available in the 7th and 8th location. Now low is 7, high is 8, and the target element that we want to search is 88. So we are going to calculate midpointer here. Now the value of 7 plus 8 divided by 2 rounded to integer 7 will get there. So now the value that is available in the 7th position is 88, and the target that we want to search is 88. So the target element was found in the given list, so that it will be returning that particular mid value as the location. So that is the 7th value, location 7 is the uh, target value. In the location 7 the target value was found there, so that 7 will be returned to user. Okay. And here is the comparison between linear search and binary search. So we are going to take different parameters like data requirement, algorithm type, time complexity, implementation simplicity, and use cases. So coming to first parameter, data requirement, if you consider linear search, so it can be applied on any sorted or unsorted list. So there is no restriction on that whether we need to apply only in sorted list. But whereas in the binary search we need to apply only on sorted list. And coming to the second parameter, that is feature algorithm type. So it will searches it will searches or examines a given target element sequentially one by one. It is a simple process. Whereas coming to binary search, so it will follows the method called as a divide and conquer by reducing the search element in the half of the elements, half of the search space. Coming to the time complexity, linear search will take order of 1 for best case, order of n for average case and worst case. And binary search will take order of 1 for best case and order of log n for average case and worst case. And implementation, coming to another feature, implementation simplicity. So linear search is very simple and easy to implement, whereas a binary search is slightly more complex, but it is a more efficient one and straightforward approach. Coming to use cases, uh, linear search is suitable for small and unsorted data sets, and binary search is suitable for large and sorted data sets. And coming to the last one, applications of searching techniques. So the first one is a databases. So whenever we have a large data set, and if you want to search for a particular records within the short amount of time, I can apply any searching algorithms like binary search, hash based indexing searching techniques for finding the records effectively in the large amount of data sets. Second one, file systems. So in a system, there as said already, we have a files, directories and subdirectories. They are all arranged in a hierarchical structure. And if you want to search for any particular file, so then we can use a tree based searching techniques like a B trees for locating a file or a directory in a given set of in a given directories and subdirectories. Next, search engines. So if you want to search for a particular web page quickly, so we can use indexing and hashing techniques to get a relevant web page from the lot of web pages that are available over the internet. Coming to next fourth one, routing algorithms. So if you want to find a path from path in a network given a source to destination, I can follow the graph searching techniques like BFS, breadth first search, depth first search techniques. And coming to the last application, spell checker. So whenever we are searching any dictionary, online dictionaries, so we will get suggestions and spelling corrections for the given word or sentences based on the binary search or tree based searching techniques, so structures. So thank you, Ananda.